Assalamualaikum warahmatullahi wabarakatuh. My name is Syazwani Binti Muhammad Zailani. Today I will present about neutron imaging. X-ray and gamma ray are high energy photons. When a photon meets an atom, it interacts mainly with the atom's electron cloud. If the atom is of a dense element, the photon cannot pass through it. This is called X-ray annutation. Neutron radiation, though, is nothing like X-ray or gamma radiation. Neutron radiation is comprised of, as the name suggests, neutron. Because neutrons are electrically neutral, they do not interact with the atomic electron of element in the way the photon or electron does. Instead, neutrons interact with the nuclei of elements. The atomic nucleus is astronomically tiny compared to the electron cloud, so there are a much lower chance that a neutron will interact with heavier elements. This gives neutron a unique ability to probe objects in a way that no other imaging method can. Imaging techniques based on neutron beam are rapidly developing and have some versatile non-destructive analyzing tools in many research fields. Neutron imaging has wide industrial and scientific significance and can provide detailed information concerning the inner structure and composition of objects. The principle of neutron imaging is based on the annotation through both scattering and absorption of the directional neutron beam by the matter through which it passes. The neutron beam can be generated either in a reactor from the neutron-emitting isotope or from a target in proton accelerator. The technique is also non-destructive in nature and has been effectively applied to artifacts and archaeological significance. The neutron imaging technique, rather than be in competition with X-ray imaging, is entirely the ideal of complementary to it, whereas X-rays are scattered and absorbed by the electron, and as some such atoms with greater electron shells interact more strongly, neutron, on the other hand, interact with the atomic nuclei. Of particular significance in high contrast between hydrogen, which interact very strongly with neutron, and most metals which offer effective transmission of neutron. This is direct opposed to X-ray imaging and offer the means to effectively visualize the dynamic of organic hydrogen containing substances in metal containers, such as the ability to visualize fuel within engines. It can also equally be used to view plastic seal or lubricants embedded within metal structure. The degree of annotation for some materials can sometimes depend on the neutron energy. For a thermal neutron, such is the case with iron. Neutron radiography involves placing the object in the path of the neutron beam and measuring the shadow image of the object that is projected onto the neutron detector, often consisting of a scintillator optically coupled to a CCD or EMCCD camera. Neutron tomography takes this a step further and entails rotating the sample in the beam and recording multiple 2D images through an angular range of 180 degrees as shown on the diagram. Neutron imaging has application for non-destructive inspection in many manufacturing industries, including the aerospace, defense, energy, automotive, medical, and construction industry. Sample applications include: first, detecting internal flaw in cast part, detecting defect in energetic materials including munition, inspecting the internal structure of additively manufactured components, detecting the presence and the position of liquids such as water inside dense metal and complex assemblies, finding evidence of corrosion inside metal pipelines, identifying bonding flaw in adhesive and disbonding of carbon fiber composite, inspecting concrete or welds for structural integrity, and detecting corrosion, humidity, and water contamination in electronic component and mechanical structure. For the conclusion, Neutron imaging has developed into a useful and practical method for different areas of materials research. New contrast mechanism beyond traditional annotation contrast allow various mechanical, microstructural, and magnetic properties of material to be revealed. Future development of this method depends strongly on progress at existing imaging facility. That's all from me. Thank you.